Thanks to you all for being here. It's a real pleasure to get to speak to everyone today. As you've already heard and will hear more, my colleagues are obviously incredible, but UCSD more broadly is an amazing place to do this kind of research. As just one small example, I was a freshman in college when Professor Molina's Nobel Prize was announced. And it was so inspiring and has remained so inspiring because I wanted to be a physicist, but in service of the public good, and there is no better example than Mario. So this is just one example of what an amazing place this is to be to study these kinds of questions. So today I want to talk about food security in a changing climate, and I want to start with the definition. So when we talk about food security, what do we mean? The working definition that international organizations use is that a food secure world is one in which all people at all times have access to the food and nutrition they need to lead the active, healthy lives they want to lead. And when we talk about food security in a scientific sense, we typically talk about it as having three dimensions. The first of those is availability. When we talk about availability, we're talking about the supply of food, agricultural production, right? The existence of enough food to feed everyone. The second axis that we talk about is called access. We want to think about if there's enough food for everyone, does everyone have the physical or economic means to obtain that food? And finally, if there's enough food and folks can access it, can they make use of it, right? Do they have the energy and clean water they need to transform that food into useful nutrition for them? I think the conceit of the past 3 decades has really been that those latter two dimensions are the only ones that matter, right? That really there's not a problem about growing enough food, there's not a problem about having enough food. It's really a question of political economy. But I'd like to submit to you today that that's not the case. And I'd like to bring to light to you a couple of facts. Again, it's easy in California. We're within 10 miles of about 40 places that look like this. We're in the salad bowl of the world. We've just eaten lunch. And so it's very easy to think that food production is not a problem. But the first thing I want to draw your attention to is that this is a plot of the percentage of the world population, the total number in red and the percentage in black of the world population that does not have enough food to eat on a daily basis. And after a decade of real optimism about progress in those numbers, that has turned back upwards. And the change is taking place mostly in communities that are agricultural, right? These are farmers that on a daily basis don't have enough to eat. The second thing I'd like to draw your attention to is that now we do not think really by the end of the century that world population is going to turn back over and start coming back down yet. That red line in the middle is the median projection from the UN most recently. And so we are talking about having to feed billions more people without having enough even at present to do so. So I submit to you that we need to figure out how to grow more food. However, at the same time, my work is at the intersection of food production and climate, and we know that right now changes that we're experiencing due to anthropogenic influence on climate are really making it harder to grow enough food. So these two systems are very tightly interlinked. On the one hand, the climate, of course, influences our ability to grow food, but on the other side, food also is a major contributor to the changes that we're experiencing. Depending on how you add it up, food production, food availability, access, and utilization contribute anywhere from 1/4 to 1/3 of emissions in any given year. My work focuses on both sides of this equation, so understanding really what world food economy and food systems do to contribute to climate, how the climate processes those emissions, and then in turn, what climate is doing to our ability to grow food and how people are responding. I'm going to start by saying a few words about the left side of this system, so how food impacts climate. I'm going to talk a little bit about how climate impacts food. So I'm going to present you with what sounds like a laundry list of problems, but I hope to end with some inspiration about also solutions that we're finding, things that work in terms of unlocking this bind. All right, so when we think about food and its impact on climate, everything about the way that we produce food matters. So our soils emit nitrogen into the atmosphere from both synthetic or natural fertilizers. When we grow rice, that puts methane in the atmosphere. All of our on-farm energy use matters when we synthesize fertilizers and pesticides. Those result in emissions. Cows burp. It has a scientific name, enteric fermentation. We just like to call it cow burps. That matters for climate. Everything about our world food system is an emitter. However, the thing that is really important is if you add up all of those emissions, they do not matter, in a sense, compared to land use change associated with agriculture, right? So if we think about the conversion of native habitats, forests or shrubland to cropland, like you see illustrated here, when you cut down native habitat, all of the carbon embodied in those trees or in those shrubs and much of the carbon in the soil makes its way into the atmosphere within a couple of decades. It might spend a few years as furniture, but ultimately it is all going into the atmosphere. And so it's incredibly important to think about growing a lot of food on the land that we have without expanding cropland, and I'll come back to that. Trade, something like 23%, quarter of emissions embodied in trade are associated with moving food around. So this is another part of the system. And again, thinking about utilization, the energy that we use to cook and process food is again a major contributor to both our emissions of greenhouse gases, but also short-lived pollutants that cause a lot of damage. There's a ton of work that goes into securing biomass, for example, right now, just to cook food on a daily basis. If we think about the other side of this system, changes in our climate system already have made it more difficult to grow food. Changes in temperature and precipitation across global croplands have depressed our ability to produce food. And to put this in some units that are friendly, when we think about technological progress over time, over the past 3 or 4 decades, we've undone about a year of progress in terms of yield growth. So climate is actually depressing our ability to just conduct agronomic research and make improvements. Another thing my group has focused on is beyond thinking about longer run temperature and climate changes, the emission of pollutants, things like precursors to ozone at the surface level, particulate matter, change our ability to grow crops as well. We change the amount of light reaching the surface. We change the chemical composition of the atmosphere that both humans and plants are breathing, and that has reduced our crop yields relative to what they would be in a clean air environment as well. Finally, when we think about climate extremes, shocks have really created issues that have long-lasting consequences. When farmers experience shocks, they often have no choice but to, for example, expand cropland or let their animals, in this picture, for example, overgraze the land. And that has a very, very long time of recovery that creates additional problems. All right, so it's easy to look at a system like this and say, System A impacts System B impacts System A. Is this just a spiral of doom? I think we've learned a couple of things that suggest hope. The first is we know that high yields matter. We're sitting not very far from the birthplace of the Green Revolution. This is the Yaqui Valley in Sonora, where Norman Borlaug conducted his famous research, spawned the Green Revolution, and really changed the world from one in which we worried about having enough food to maybe the past few decades where we haven't really thought so much about it. But one of the unforeseen consequences of the Green Revolution was actually that it spared a lot of native habitat from being converted to cropland. We estimate that it's something like 1/3 of emissions since industrialization were spared almost by accident. So we know this is a technology and a strategy that works. We need to keep yields high. The second thing we're learning is that it's possible to help farmers buffer against shocks, buffer against variability in climate. So here's a picture from Brazil, helping farmers grow new kinds of forage crops like prickly pear cactus, which it turns out, in addition to making good tacos, is very good for livestock feed. We also have done some work in West Africa, helping women grow crops year-round, buffering against seasonal swings that contribute to both land degradation and malnutrition. Finally, we need to think about new ways to monitor the world food system at much higher frequency temporally and spatially. So in conjunction with the Big Pixel initiative here at UCSD, we're trying to develop new methods to understand what's going on. So here's some visible imagery of the Imperial Irrigation District, lots of alfalfa being grown there. It all kind of looks the same. We're developing new methods that help us understand in much finer detail and at much finer timescales how many cycles of crops are being grown in what place and what's being grown. I want to leave off with this picture. This is what's known affectionately as the Doomsday Vault. This is a seed vault in Svalbard, Norway, the highest latitude location with a commercial airport. And this was designed to hold the world's crop genetic resources and to use the permafrost, right, Earth's natural refrigerator, to keep these seeds in decent shape in the event of catastrophe. Well, it most recently made the news because something like $13 million had to be spent to fix a leak because the permafrost was melting faster than anticipated. So I'd like to end by saying this set of systems has connections that we're only beginning to discover, and new ones keep popping up every day. So I'm grateful to be in a place like GPS where we can try to keep a better pulse on this very important system. Thanks.